Good morning. I am K. Palnivel, Assistant Professor of Mathematics, SNS College of Technology, Coimbatore. Today, I am going to the topic Poisson Distribution. What is meant by Poisson Distribution? Definition: a random variable x is said to follow Poisson distribution if it assumes only non-negative values of its probability mass function PMF. Probability mass function is given by P of x equal to x, capital X equal to small x, equal to e power minus lambda into lambda power x divided by x factorial, comma, x equal to 0 to infinity is the limit, where lambda is a parameter given lambda equal to np. Next one, property of Poisson distribution. Binomial distribution is a limiting case of Poisson distribution and n tends to infinity, comma, p tends to 0. Next one, movement generating function mean and variance of Poisson distribution is movement generating function mx of t equal to summation x equal to 0 to infinity e power tx into p of x. Summation x equal to 0 to infinity e power tx into p of x equal to summation x equal to 0 to infinity e power tx into e power minus lambda into lambda power x divided by x factorial. E power minus lambda into x equal to 0 to infinity summation x equal to 0 to infinity e power tx into lambda power x divided by x factorial. E power minus lambda into summation x equal to 0 to infinity lambda e power t lambda into e power t whole power x divided by x factorial. E power minus lambda into lambda e power t whole power 0 divided by 0 factorial plus lambda e power t whole power 1 divided by 1 factorial plus lambda e power t whole square divided by 2 factorial plus etc. etc. Therefore, e power minus lambda into 1 plus lambda e power t divided by 1 factorial plus lambda e power t whole squared by 2 factorial plus etc. etc. Therefore, e power minus lambda into e power t into lambda, e power minus lambda plus lambda e power t. Next, the movement generating function is e power t minus 1 into lambda. Mean e of x equal to d by dt of mx of t at t equal to 0. d by dt of e power t minus 1 into lambda at t equal to 0. e power t minus 1 into lambda e power t at t equal to 0. Lambda into e power minus 1 into lambda. Therefore, lambda into e power 0. e power 0 is 1. Therefore, the mean value is lambda. Next, variance. Variance formula is e of x square minus e of x the whole square. E of x square equal to d square by dt square into mx of t at t equal to 0. d by dt of lambda e power t into e power t minus 1 into lambda at t equal to 0. Lambda into e power t into e power t minus 1 into lambda e power t plus e power t minus 1 into lambda into e power t at t equal to 0. Lambda into e power 1 minus 1 into lambda plus e power 1 minus 1 is 0. Therefore, lambda into lambda plus 1. Therefore, e of x square equal to lambda square plus lambda. Therefore, variance of x is e of x square minus e of x the whole square. Therefore, lambda square plus lambda minus lambda square equal to lambda. E power lambda into e power t minus 1. Mean equal to lambda, variance equal to lambda. Next one, if the Poisson variate p of x equal to 2 equal to 9 into p of x equal to 4 plus 90 into p of x equal to 6. Find mean and variance. Solution: mean and variance of given Poisson variate values. Poisson distribution p of x equal to e power minus lambda into lambda power x divided by x factorial. Given p of x equal to 2, substitute the value of x. First one value is 2, second one value is 4, next 90 into third one value is 6. Substitute this x value, we get the value of lambda power 4 plus 3 lambda squared equal to 4. Substitute this value, finally subtracting and substituting these values of lambda cube plus lambda square plus 4 lambda plus 4 equal to 0 and lambda equal to minus 1. Factorize the value, we get the lambda value is lambda equal to minus 1 comma 2 again minus 2. Therefore lambda equal to we have to take the lambda value is positive, therefore mean and variance equal to 2. That's all. Thank you for watching.